Hello, my name is Wolfgang Heinbach. I'm the Managing Director of GMP, German Machine Parts, DDM, Data and Documentation Management, and Chairman of the Component Obsolescence Group in Germany. I will talk about smartPCN and how to apply it to digital obsolescence management. Let me give you an overview about the content. First, I want to speak about the world of product change notifications. How does it look like today? After that, let's have a look on the digital vision which is made possible by smartPCN. The next part is the smartPCN ecosystem. The ecosystem is supported by pcn.global and pcn.cockpit. Those are professional products. And finally, I talk about the digital obsolescence management, ending with a summary. Obsolescence management relies on product change notifications, or PCN, including discontinuation or end-of-life messages. PCN are usually sent by suppliers when a product is changed or even discontinued. The colored little boxes represent the various PCN. Each manufacturer uses its own formats of PCN. On the next level, this may lead to changes or discontinuation as well. Here also PCN are sent out to the users of the product. Depending on the nature of the PCN, it may lead to an obsolescence case on product level as well. Looking at the overall number of PCN just in the electronic industry, we see a dramatic rise of the number of PCN. Each day, about 50 PCN in average are issued worldwide. There are not just PCN for electronic parts. Software, data, services, tools, spare parts, and even materials are modified or discontinued every day. Now have a look on the overall situation within the supply chain based on a simple example. Imagine there is a chip. It is used on a printed circuit board. The board is used within a control unit. There is software for that board. And the whole thing is used within a product or production line. The dashed lines indicate company borders. On every stage, modifications or even discontinuation may occur. They are usually communicated with PCN via different media like personal information, email or PDF in various different formats. Therefore, you need on each stage skilled experts to read, process and evaluate the PCN, as well as start actions to cope with. That is a lot of effort spent on each stage. It takes time to process, and there may be a long time from the reception of the first PCN until the end user gets the information. Whether you receive in Egyptian papyrus, a Babylonian clay tablet or a PDF, you have to read it and extract the information you need manually. But there is more to it, looking like playing the Chinese whispering game. The supplier sends out PCN which may go to a distributor. After some time needed for processing, it is usually sent to the procurement department. Here it is processed as well and sent to the responsible for parts management. Here again, after some processing time, it is received finally by the R&D or production department as the final destination. There may be interruptions and the chain may break down. But usually there are several distributors involved, which send out PCN at different times. And also there may be several procurement departments from different sites or even at subcontractors. At the end, not all PCN sent out will reach their destination, but some of them will receive multiple. As a result, we have sequential processing, we have doublets. We depend on processes of different companies. It is error prone, has the risk of communication gaps, and altogether needs a lot of time for processing and the overall throughput. Looking at the receiving side at a company, the situation is quite complex. There are a lot of PCN. Some of them are even multiple available, coming in different formats via different media, all flooding the responsible person for PCN processing, who is in rotation because ERP systems, engineering system and emails need manually to be fed with the PCN information. Why email? Because usually the different organizations are informed via email and they by themselves need to manually process the PCN. So there are many manual interfaces and media breaks on the way. In order to keep track with the status, usually large spreadsheet tables are used which need constantly updates. All this is time consuming, resulting in a high throughput times or overall delay as well. It is a high workload for those responsible because within the company proper action can be initiated only when information is available within the company's systems and in the appropriate format. So this stage may lead to a bottleneck situation. The world of PCN is analog, resulting in media breaks. We need manually perform data transfer, need to search for numbers and do even research for additional information that is missing in the PCN. So we have data processing by humans, in particular copy-paste actions, having the risk of creating errors, and highly skilled experts spend a lot of time with manual activities, filling out spreadsheets instead of management activities to solve problems. In particular, in times where expert know-how is rare, it is very difficult to increase the staff in order to keep track with the increasing number of PCN. So the whole process has a low efficiency, creates high costs and has a high risk of errors and data loss. Just imagine, in the digital age, we are working like in the beginning of the industrial era. Is there a better way? Within the COG Germany, a working group started to think about a much better and modern way. This is the digital vision. Imagine there are digital processable PCN. That means they look all similar, having a defined format in order to be processed digitally. They come into the company through some gate, letting information in but not out. And of course, you want only those which are of interest for you. Internally, the PCN are immediately stored within a database with direct connection to ERP and engineering systems, where information can easily be exchanged via direct interfaces. Also, the different organizations can directly access the database, and those with actions to do can be informed via email automatically. A specific PCN can be processed directly from the database, entering information into the database and visible for all involved. Also, keeping track with the status is much easier, because this can be part of the database as well. That makes the PCN manager quite happy, because it requires less time, causes less delay, the workload per PCN is much lower, and a PCN manager can much more concentrate on all management activities with focus on solution finding. The digital vision does have a lot of advantages. Because all media or PCN are in one place, the data processing is performed by machines, allowing people to focus on obsolescence management activities. It supports to focus on management as well as solution finding. Also, processes can be much smarter and be kept simple. Everyone who needs to be involved can have access to each PCN immediately, and it supports the critical resources of obsolescence experts. So in total, it is much more efficient, saves times and costs, and reduces errors and data loss as well. But we need a second part for the digital vision, the supplier side. As with many digital systems, it would be good to have a cloud, a database within the internet which contains digital PCN. Therefore, it would be a great thing if manufacturers would provide digital PCN for that cloud. However, not all will do this in the beginning, and they will also provide PCN in the existing analog format. What about distributors? They can also provide PCN because they have to process PCN anyhow. They would also benefit from already existing digital PCN. But again, Not all of them will do it and still provide analog PCN. This is the time for companies providing data services. They can easily provide digital PCN, so a stream of digital PCN can be provided for all users. The big advantage of the cloud principle is that a lot of companies and users can contribute in order to provide digital PCN. As soon as a PCN is available in digital format within the cloud, everyone can use it, saving the effort for manual processing and conversion. Bringing both sides together, we just need to think about mechanisms how to get just those PCN you really need. Again, suppliers and distributors need to feed a global PCN cloud. In case they don't, data service companies can jump in, converting analog PCN into digital PCN. Digital PCN can be loaded into a local company database or internal cloud with interfaces to existing company systems. And each person involved is able to access the database independently. What we need is a mechanism that allows us to download just the digital PCN fitting to our data in the ERP system. This would allow a digital, standardized and machine-readable PCN flowing into the local database and subsequently the other company systems. But it needs to work the way that company-related information is not disclosed to third parties. How can we make that working? In order to enable a barrier-free flow of digital PCN, we need three things: commonly used terms and definitions, a standard, PCN that are digitally processed, and an ecosystem to create, handle and work with digital PCN. The COG Germany did within several years of voluntary work a comprehensive research on product change notifications. How do they look like? What is the information contained? The result is smartPCN, a communication format for PCN. Now, how does it work? Just look at the classic PCN. In order to get to a smart PCN, we have to extract information, do categorization and classification by looking at the content of a PCN. The results are stored using a standardized format which is based on XML and contains different sections like master data or part numbers. This information is stored in an XML file called body. The original PCN is stored as well as an attachment or as several attachments. Everything is stored within one single zip file. Now we have inside the smartPCN files for processing via machines and files intended for humans with all written information for experts and engineers. So we have in one single file digital processable information and documents for humans included. Within the attachment section, it is also possible to store another smartPCN. This offers completely new possibilities within the supply chain. Starting with a chip, we create a smart PCN for modifications or even end of life. Changes made to the PC board are documented within a smart PCN that includes the smart PCN of the chip. Changes on the level of the control unit are documented in a smart PCN that includes the smart PCNs before. Also for the software there is a smart PCN. In total we get now one single smart PCN file which includes the smart PCN of the subunits down to the chip. So all modifications along the supply chain are documented in one file and the nested smart PCNs inside. This is not possible with all previous methods, and one of the big advantages of smart PCN. It is not mandatory to use it that way, but it is a built-in feature. It requires still people to process and create PCN, but the overall effort is much lower. We have now a standard But if nobody is providing PCN in the smart PCN format, nobody can use the benefit. In 2016, DDM Data and Documentation Management has started as a business partner of COG to create a smart PCN database called pcn.global. By July 2017, there are more than 10,000 smart PCN available without doublets, which cover more than 500,000 part numbers. The PCN do come from manufacturers. From distributors and data services are PCN received and converted, and from companies who forward their received PCN to PCN Global. The more sources there are, the better is the coverage of PCN. An expert team takes care of the conversion and the quality control of each smart PCN. And finally, from the PCN Global database, smart PCN can be sent outside. Looking at the smart PCN ecosystem, we have now 5 components. We have the PCN Global database, a smart PCN viewer provided by the COG. This is comparable to a PDF viewer. The pcn.cockpit, a PCN and obsolescence management system. Smart PCN from suppliers, for example from Isos. In future from OEM that provide smart PCN for their products. This system is fed with conventional PCN. Important is that smart PCN is not limited to electronic components. Any kind of product change can be documented. At the VDMA, the Mechanical Industry Association Germany, a working group did like the approach of smart PCN. There is now a local standard called Einheitsblatt, currently in review and released later in 2017. The extension defined in the Einheitsblatt will be taken over in the smart PCN standard. Next year, an international standard is planned out of the Einheitsblatt. How can digital obsolescence management be realized using smart PCN? Here is how it works. There is the PCN Global database, and there is the PCN cockpit. There is a local database inside the cockpit. The PCN Global database is in the cloud, while the PCN cockpit runs inside the company. Because it is inside the company, your company, it can connect to ERP and engineering systems, loading material lists, bill of materials, and master data. The PCN Global database sends information about all stored part numbers to the PCN cockpit. With that information, the PCN cockpit is able to search for matches and can do a mapping between the different data. In case there is a fit, the related smart PCN is downloaded into the local database. Then internal workflows for analysis and measures can be started. The documentation is an integrated part of the database. Affected organizations can be reminded by email. And finally, data can be migrated into the ERP and engineering systems. What is important? All data stay inside the company. There is no information about material lists, bill of material, or workflows and analysis results given outside the company. Going back to the beginning of the presentation, where we have analog obsolescence management, we first exchanged the supplier side and introduced digital PCN. Already this step reduces workload and saves time because all PCN are formatted the same way. Then we enable the receiver side to process digital PCN, resulting in further workload reduction. We have now a connection to download only specific PCN into the database. The database reduces workload even more because all information is at one place. In total, throughput delay and processing time are reduced, and workload is distributed over many participants, making things easier. When we talk about digital obsolescence management, we want to have it really 100% digital without media breaks but continuous processing with as few manual interactions as possible, and for all industry sectors, not just electronics. smartPCN and VDMA 24903 are the base for the exchange of machine-readable digital PCN. We gain speed because it is more efficient, faster, less work, and allows for distributed workflows. The approach we have taken with pcn.global and pcn.cockpit combines the advantages of digital processing with data and information security because it is not necessary to send company internal data to where you have no control. Algorithms and big data approaches can be applied in future to the PCN in the global database as well as those stored internally. The Smart PCN format offers a lot of flexibility to allow its application to reach relevant messages as well as PCN for standards and standard parts. Finally, as a summary, I want to emphasize, in a digital world, also PCN need to become digital, saving effort, time and making the work easier for highly skilled experts. With Smart PCN, COG Germany has developed and realized a fully digital standard for PCN communication, which is now adopted and extended by a working group at the VDMA. We have proof of concept with commercial tools available for professional work, the PCN Global Database and the PCN Cockpit. Thanks a lot for your attention. Here you will find links for further information. Please feel free to contact me in case of questions.